A formula for the relationship between the weight and the blood pressure in the children is given by the formula P of x is equal to 13.9 times 5 plus ln x, and this formula is valid when the value of x is between 10 and 100. Here the weight is x and then blood pressure is actually represented by P of x. And remember, we have also given P of x is measured in millimeters of mercury and x is measured in pounds. So those are the given units. This is just the given information where we just have this formula, which is actually a relationship between the weight and the blood pressure. What is the question here? The question here is to find what is the rate of change, right? Rate of change of the blood pressure. So our goal is to find the rate of change of the blood pressure with respect to the weight. How do you find the rate of change of the blood pressure with respect to weight? What is blood pressure? The blood pressure is actually P of x, right? So that's what we have given. So this is your blood pressure. And if our goal is to find the rate of change of that, then actually P prime of x, when we do that, this will be the rate of change of the blood pressure with respect to x, or with respect to the weight. Okay, so that's how we can find. But here, if you revisit this question, our goal is to find the rate of change of the blood pressure with respect to the weight at the 30-pound weight level. That means our question is, we need to figure out the derivative of P, right? So we need to figure out the derivative of P with respect to x at x equal to 30, or what you can say is you need to find f prime at 30. So this is the question you need to figure out. So when we extract all the necessary information over here, let's try to formulate this. So we have given P of x equal to 13.9 times 5 plus ln of x. So this is the relationship between the blood pressure and the weight, and our goal is to find P prime of 30. Okay, so based on this given information, we now formulate everything. So let's just focus on this. Okay, so we have given P of x, right, which is 13.9 times 5 plus ln of x, and our goal is to find P prime of 30. But how can you find P prime of 30? What is P prime? P prime means derivative of P with respect to x at P prime is derivative of P with respect to x, right? And then we need to evaluate that at 30. So if that is the case, we need to find P prime of 30, we actually need to figure out what is P prime of x. Of course, the main question is this, but we first need to address this one. Okay, so let's try to find that. So how, if P of x is given as 13.9 times 5 plus ln of x, then how do you find P prime of x? So how do we find the derivative of this? You can see here we have a constant multiplied by some function, so we can use the constant multiple rule, which is leave the constant as it is, right? So 13.9 as it is, multiply by the derivative of 5 plus ln of x. Alright, so 13.9 is as it is. How do you find the derivative of 5 plus ln x? We can first find the derivative of 5. We can also find the derivative of ln x and then add them together. Right, so that's what we need to find it. So let's try to. So if this is the case, then you can see here this is 13.9, and what is the derivative of 5? Derivative 5 is a constant, so derivative of 5 is 0, plus what is the derivative of ln x? The derivative of ln x is 1 over x, right? So we can just write that down. So 1 over x. So 13.9 over x is the derivative of the function, derivative of the P of x. So if that is the case, rate of change of the blood pressure with respect to x is 13.9 times 13.9 divided by x. Okay, so that is our P prime of x. So what we have figured out is P prime of x, which is 13.9 divided by x. But our goal is to actually find what is p prime of 30. But since we already have the p prime of x, right, so we just need to evaluate that p prime of x at 30. So how can you do that then? Then we just need to replace over here, replace x by, so that means over here, right, we need to evaluate the p prime of x as 30. So that means let's just evaluate, let's just write down 13.9 as it is, divided by, let's just replace by 30 x by 30. So we get this. So 13.9 divided by 30 will be approximately equal to 0.46333. So this is your approximation. So this is what we get as a rate of change of the blood pressure with respect to x. And since the p of x is measured in millimeters of mercury and x is measured in pound, so if that is the case, then if you want to write down the unit, this can be written as 0.463 millimeter per pound. All right, so this is your work and this is the required answer.